This is lesson 3.5, and we're going to be talking about factoring a difference of squares and perfect square trinomials. So let's talk about a difference of squares first. This is a difference of squares, and you can recognize it because it is a binomial, which means that there are two terms. It's separated by a subtraction because it's called a difference, and difference means minus. Okay, now when they say squares, what they mean by that is perfect squares. So these two, this a squared and this b squared, are both perfect squares, as in if I wanted to square root them, I could without it getting too messy, like with decimals or whatever. So a difference of perfect squares. See, a minus of perfect squares. Now, we had seen this before in a previous lesson where we learned about three special products. And so one of the three special products had two brackets that looked identical, except for the fact that there was one plus and one minus. Now, when we did the distributive property and we multiplied everything in, so a times a times negative b times a, and then b times negative b, and we simplified it, so we expanded and then we simplified, we actually got the difference of squares as our answer. Now, I want to show you that we can go backwards. If I recognize the difference of squares, could I then go backwards into the brackets? And yes, I can. It's actually pretty simple. All right, so this is what you do. First of all, obviously, you set up the brackets, one with a plus and one with a minus. It really doesn't matter which one is the plus and which one is the minus. But in order to get your a's, what you're going to do is you're just going to square root this first term. And remember, it has to be square rootable for it to work. If it's not square rootable, then it's not a difference of squares. Okay, so the square root of a squared is just a, and since it's at the front, you're going to put it at the front of each of the brackets. Now take the square root of b squared. I'm going to do that in blue. And that is going to give us just b, and you're going to put that at the back of each of the brackets. And that's it. All right, let's take a look at some questions, and I'll show you, and you'll kind of get it as we go. This is a difference of squares, and so is this. You can see that there's a minus in between, and then on either side of the minus are square rootable terms. So it is looking very similar to the formula, especially if I line it up. Do you see like the minus, and this one is our supposed a squared, and this one is our supposed b squared. So since I know that a squared minus b squared is equivalent to these two brackets, why don't I just get rid of this and say that the original question will equal to something in brackets. Let's get rid of that period. Okay, but you see there's no a's or b's in the original question, so what is my a and what is my b? Well, remember that we get the a's by square rooting that first term. So if we square root the first term, the x squared, we're going to get x, and they're going to go where the a's are. Now to get the b's, you take the square root of the last term. So the last term is 16. The square root of 16 is going to be 4. And so we're going to put that right there and there. And so those are our identical brackets. If you actually wanted to check your answer, you could always do distributive property, simplify it, and then you should get something like this. All right, let's try the next one. I do recognize that this is a difference of squares, because this is square rootable and this is also square rootable. There's a minus in between. And so if I copy and paste this formula, okay, and put it right underneath, you can see this is going to probably give me my a's, and this is probably going to give me my b's. And so that's what the answer should look like. Now, in order to get the a's, again, you're going to square root this first term. So the square root of 9 is 3. And then we're going to square root the x squared. All right. To get the b's, you're going to square root that last term. So the square root of 1 is just 1. And that is our final answer. All right, now when I take a look at that third one, it looks like it's actually trying to play a trick on me. I do see the minus, but it doesn't look like this is square rootable because you can't take the square root of 5 without getting decimals. Same with the 20. So actually I'm noticing that 5 and 20 can both be divided by 5. Why don't we take that 5 out first and then see if we're actually left with a difference of squares. So equals, and then let's take the 5 out. We're going to factor. All those leftovers are going to go into brackets. So this guy divided by 5 is x squared minus 20 divided by 5 is 4, and then the y squared. All right. Now this is a difference of squares. You have a minus and you have something square rootable over here and something square rootable over here. So what I'm going to do is I'm going to copy and paste my answer like that, put it right there. Okay. And so to get the a's, we're going to square root this guy first. So the square root of x squared is just going to be x and x. Then we're going to look at the back, and we're going to square root that in order to get our b's. Square root of 4 is going to be 2. Square root of y squared is going to be y. All right. Now just don't forget that there was a 5 in the front, and so we're just going to leave it there. All right. So we factored the difference of squares in this bracket, and we also common factored a 5 out of the original. So that's difference of squares. Why don't we talk about perfect square trinomials? There's 2 more special product formulas. And what we had done previously is when we saw something like this, we knew that we had 2 brackets of a plus b. So after doing the distributive property, we get something like this. And so recognize the only difference between the 2 formulas is this dictates that you have a positive in the brackets, and this one will dictate that you have a negative in the brackets. Other than that, like both 2 formulas look almost exactly the same. So you need to be able to recognize which one you have. And if I'm looking at the very first example, it looks like this one, mainly because I have that green negative right there, that positive is right here. But there is actually something further. If you recognize that the first term, a squared, is square rootable, I would square root that, and that would be a portion of my answer. Take the back one and see if it's square rootable. That will also be a portion of your answer. Okay, the middle part, what you want to do is kind of use that as almost like a check. So you can check to see if it actually works out, and I'm going to show you how to do that in a second. So first of all, I'm noticing that yes, this is square rootable. This is going to be the red one. And the very last number is also square rootable. And again, there was a minus right here. I'm recognizing that it's probably this formula, which means the answer should look like this. All right. Now, if we square root the x squared, that's what's going to go in the front. And if we square root the 9, that's what's going to go at the back. And that is our answer. Now it says that they want us to verify just to make sure that it is correct. And so we're going to verify this middle part. If we take our A and we take our B, so whatever was A and whatever was B, we multiply them together and double it, it should be this middle term right here. So x times negative 3 is going to be negative 3x. Doubled would be negative 6x. So this is the correct answer. Let's try that again. So this one right here, I'm recognizing looks a little bit like this formula, mainly because we have the minus right there, And then we also have square rootable items at the front and at the back. So I'm going to take this guy, again, put it right there. Okay, so this 9x squared is in red. I'm sorry, I can't highlight it in red just because it's a different software that I'm using. So it's hard for me to edit it. But the 9x squared is going to be square rooted into 3, because 9 square rooted is 3. X squared square rooted is x. The blue b right here is going to be the square root of the 16, which is 4. Now the way that we're going to check is with the negative 24x. We want to make sure that it's actually equivalent to double the a and the b multiplied together. So here is my a, which is 3x. Here is my b, which is the 4. Okay, so 3x times the 4 or times negative 4, however you want to think about it, is negative 12x or 12x. Now if I double that, I will get the 24x, which checks my answer as correct. Let's do one last one. So this one down here, a plus and a plus, so I'm thinking it looks kind of like this one now, the top one. All right, and I want to make sure that the front and the back are square rootable. So yes, this one is square rootable. All right, and so is this one, square rootable. So its answer should look like this. Okay, where a is the square root of the red and b is the square root of the blue. So the square root of y squared is going to be y, and the square root of 4 is 2, and the square root of z squared is just z. So that should be the answer, but I just want to check to make sure. And again, the way that we do that is we double the a and b together. So if I take your a, supposedly in this question is y, and the b, which in this question is a 2z, and I multiply them together, I'm going to get 2yz. Now remember, you're going to double that answer. So 2yz doubled should be 4yz, and that actually doesn't match this middle term. So this is actually not the right answer. If you decided to expand it, it would actually give you something different than this. In this case then, I would say not possible. Or if you want to, you can write not factorable. All right, so it's not actually possible to factor it using any of the special products. Okay, so that was a lesson on how to factor those 3 major formulas that we had learned, which is the difference of squares and 2 perfect square trinomials.